This video will be on how to do hypothesis testing when you're going to find the p-value. And we'll discuss what the p-value is in a second. But to start out with the hypothesis testing using the p-value, I'm going to give the steps again. Luckily, the first couple steps are the exact same as the traditional method. So the first step is to read through the claim. Let's decide if the claim is about a population mean or a population proportion. If the claim is about the proportion, you need to find the sample proportion, which is your x over n. And if the claim is about the population mean, you need to check and see if you have a population standard deviation, which is where you'll use the z-score, or a sample standard deviation where you use the t-score. Step 2 is to write out the null and the alternative hypothesis. So my null hypothesis, once again, is H0, and my alternative hypothesis is H1. The null will have some sort of proportion is equal to, not proportion, but parameter. A parameter is equal to. And the alternative hypothesis will have the parameter either less than, greater than, or not equal to. Next, let's move on to step 3. We're going to determine the significance level. So that will be our alpha. Then we need to make sure we know if the significance level is two-tail or a one-tail test. So what we have here is, there's our graph. A two-tail test would put our significance in both of the tails. A one-tail test would either be on this side, the left side or the right side. Okay, and that would be alpha for each of those significance levels. Okay, now let's move on to step 4. So step 4 is to find the test statistic. So you have 3 different test statistics. These are the same as the previous video. But if the test statistic is about a proportion, it will be p hat minus p over the square root of p times 1 minus p over your n. So that's for proportion. If our claim has a mean and we know the population standard deviation, we're going to have x bar minus the mean over your population standard deviation divided by the square root of n. And if our test statistic is a mean where we do not know the population standard deviation, it's pretty similar but not exactly the same as if we do know the population standard deviation. The only difference is we divide by the square root of our sample standard deviation. So these will be the 3 different test statistics that you will need to find. Pick which one depending on whatever the original claim is asking. All right, so now let's move on to step 5. Step 5 is where it gets a little bit more unique than what we've seen before. All right, so for step 5, you need to find the probability of the test statistic that we just found, and that is called the p-value. If the area is a two-tail test, we do need to double the p-value. However, if you do use Excel to find the t-score, and you can also use Excel to find a z-score distribution, it can give you the two-tail probability so you don't have to double it on your own. So on Excel, what you need to use is you need to know if you have a left tail, a right tail, or a two-tail test, which you should have found up here anyway with these graphs. So if you have a left tail test, you will use this ti.dist. And then it will have the parenthesis, and you'll put your t-score you found and the degree of freedom that you need. Okay, if it's a right tail, you'll use this in the same concept, and two-tail, same concept right there. So that's how you find the probability or the p-value of your t-score. So once we find the probability of our test statistic, the step 6 will be the next step, and it's just going to compare those two. So step 6 is to compare the significance level, our alpha, to the p-value. So we have two things happen here. If our p-value is less than our alpha, meaning our probability of our test statistic is smaller than our alpha, we will reject the null. If p is greater than alpha, we fail to reject the null. Just to put that into perspective a little bit, so what we're having is we have a significance level. Let's say we have a right tail significance level. If our p-value or our probability is smaller than the significance level, so let's say this is our probability right here. See how our test statistic would be inside the critical region. So if our p-value, the probability of our test statistic, if that amount is less than our actual alpha, then we just reject the null. If it's greater than, that means it would be like out here, and it would be greater than our null, or greater than our critical region, greater than our alpha, so we would fail to reject the null. So the last step, step 7, is to use the flowchart to help you write the final conclusion about your claim. All right, so if you remember, we decide, does our original claim contain equality? If it's yes, then we need to decide, do we reject the null or not? If we go yes, we have the top one. No, we go down. So you just kind of follow the flow of the chart, hence the word flowchart, to figure out how to word your final conclusion. All right, if you feel like you understand the p-value method of the hypothesis testing, that's great. I am on the next slide in this video going to do one example so you can see how to do it if you need that. If not, you can stop right there. All right, so a recent study took a sample of 125 car accident deaths and found that 97 of those deaths, seatbelts were not worn. Test the claim that more than 75% of all car accident deaths are caused by not wearing seatbelts. Well, there could be other things besides the seatbelts, but let's just test the claim based off of the study we have here. Now, we are testing a claim about a proportion, so we do need to find our sample proportion. So our p hat is going to be x over n, which will be the 97 out of the 125. So that means our p hat is going to be equal to 0.776. So we have our sample here. We're going to use that for a couple things, so we need that. So the next thing here is we need to write the null and our alternative hypothesis. So the null here is that our probability is, our original claim is that the probability is greater than 75%, or the proportion is greater than 75%. So the null is always, the probability is not equal to 0.75. Notice I changed that to a decimal. And the alternative hypothesis is that my population proportion is greater than 0.75. Now, we need the null hypothesis to make a conclusion, and we need our alternative hypothesis to test what tail we're using. So with the tail on here, we have a right tail test because it's more than 0.75. Our significance level, I'm moving on to step 3 here. Our significance level, our alpha, it's not given to us, so we're going to use 0.05. This means that we have a z-score test where we have our alpha is 0.05. So now the next step would be to find the test statistic that goes along with our probability, or rather proportion. So we have z is equal to p hat minus p over the square root of p times 1 minus p over n. So you should be getting somewhat familiar with that formula. If you've gotten to this point, you've used it a bunch. So I have here z is equal to your p hat, so 0.776, minus your p, which is 0.75, that's the claim value, divided by the square root of your claim value times 1 minus your claim value, all over the square root of n, so the square root of your total sample. And we just need to go and calculate out what that z-score is. So I get the answer, my z-score, to be 0.78. It's a pretty low z-score, but there's my z-score, so 0.78. So now what I'm going to do is I'm going to use my chart, my z-chart here, to find the probability or the p-value of the z-score, 0.78. Now remember, we want the area to the right here, so we will need to go 1 minus that. So let's look at our chart. All right, our chart, we have to find 0.7 and then 8. So we have 0.7. If I can draw a straight line, that would be great. 8. So right here where they meet is 0.7823. So we get 0.7823. However, that is the area to the left. So remember, you need to subtract 1. 1 minus 0.7823. Which will be 0.2177. All right, so my p-value is 0.2177, and my alpha is 0.05. All right, I'm having a formatting problem, but that's okay. So we need to compare these two. We need to decide, is p less than alpha or is p greater than alpha? So this should be somewhat obvious that the p-score is greater than the alpha, because we have 0.2177 is greater than 0.05. So because our p-value is greater than alpha, we are going to fail to reject the null. And because we are going to fail to reject the null, we need to figure out how we are going to write the claim. So our original claim was that it was greater than 75%. So we have here, does our original claim contain equality? No, it does not. Did we reject the null? No, we failed to reject the null. So now, this is right here how we would write our final conclusion. So there is not sufficient sample evidence to support the claim that more than 75% of all car accident deaths are caused by not wearing a seatbelt. So once we get the conclusion to our hypothesis test, we have solved the problem fully. We just need to know, is our claim supported or not? So we cannot support the claim that we made.